Hello bachcho, let's read this question. So the question says that which of the following statements are incorrect, is or are incorrect. So we have four statements and we have to find out which statement is correct or incorrect. So let's solve this question. So first we have 0.1 molarity KCl and 0.1 molarity glucose. So we have to compare the osmotic pressure. So KCl is electrolyte, that means it's dissociated to form K plus and Cl minus, and for glucose Venter factor is 1 as glucose is a non-electrolyte. So for non-electrolyte Venter factor is 1. So here number of dissociated ion is 2, and if we'll find out the Venter factor, then it will be equal to 1 plus N minus. So here N is 2. So 2 minus 1, as alpha value is not given, so it is 1, and it will be equal to 2. So we know that the formula of pi is ICRT. T is constant, R is constant, C is same in both cases, that means it vary according to I. So more is the value of I, more is the osmotic pressure. So if we'll see or compare between the 0 KCl and glucose, then KCl has more osmotic pressure than glucose because I value is 2 in case of KCl and 1 in case of glucose. So osmotic pressure of 0.1 molarity solution will be higher than 0.1 molarity glucose solution. But statement says that they have same osmotic pressure. That means option A is incorrect. Now option B. So option B is 0.1 molarity KCl and 0.1 molarity urea solution. So urea is a non-electrolyte. That means Venter factor for urea is 1 and Venter factor is KCl is 2. As we have already find out the value of Venter factor for KCl. So now boiling point of solution is equals to boiling point of pure solvent plus I into Kb into molality. So molality is same in both cases. Kb is constant. This is also constant. Only it varies according to I. As it is the addition between the vapor boiling point of solvent plus I into Kb into molality. That means if this part will be higher, then boiling point of solution also be higher. So I value should be more. If you see, then KCl has Venter factor value, more Venter factor value than in comparison to urea, as KCl has Venter factor value of 2. So boiling point of KCl will be more than boiling point of urea solution. But according to statement, it says that 0.1 molarity KCl solution will have the same boiling point. So it has not the same boiling point as I value varies here, and it also depends upon the value of I. So 0.1 molarity KCl have more boiling point than in comparison to 0.1 molarity KCl solution. So option B is also incorrect. Now option C. So option C is 0.1 molality glucose and 0.1 molality urea. So both are non-electrolyte. So for both I value is 1. For urea also I value is 1. That means here I1 is equals to I2. Venter factor same and osmotic pressure only depends upon Venter factor CRT, and concentration is same, temperature constant, universal gas constant, as it only depends upon value of I, as in these two cases I value is same, that means concentrate or osmotic pressure will be same, and same osmotic pressure, that means isotonic. So option C is correct. Now option D. So option D, 0.1 molality MgCl2 and 0.1 molality NaCl. So MgCl2 dissociate to form Mg2 plus 2Cl minus. Here number of dissociated ion is 2. So if we'll find out the Venter factor, then 1 plus n. So in place of n there is 3 because the number of dissociated ion is 3 minus 1 into 1. 1 is the degree of dissociation. So it will become 3. And in case of NaCl, it is substituted or it is dissociated into Na plus plus Cl minus, and here in this case I value is 2. So the question says that MgCl2 solution will have less relative lowering of vapor pressure than 0. So we know that the formula of relative lowering of vapor pressure is it is generally del P by P naught, or we can say that relative vapor pressure generally is equals to I into mole fraction of solute. So it only also directly proportional to, or we can say that relative lowering of vapor pressure directly proportional to Venter factor. More will be the Venter factor, more will be the relative lowering of vapor pressure. That means 0.1 molarity MgCl2 solution have more relative lowering of vapor pressure than 0.1 molarity NaCl, as the value of Venter factor in case of MgCl2 is 3 and in case of NaCl is 2. So option D is also incorrect. So according to question you have to find out the incorrect statement. So option A, B and D are incorrect. 0.1 molarity KCl solution will have the same osmotic pressure as 0.1 molarity glucose solution, and also 0.1 molarity KCl solution will have the same boiling point as 0.1 molarity urea solution. This is correct. And option 0.1 molarity MgCl2 solution will have less relative lowering of vapor pressure than 0.1 molarity NaCl. So this is also incorrect. So option A, B and D are incorrect. Hope you understand it well. Best of luck.